Hello, this is Akhil Chandel, and in this video, I will be presenting an analysis and a critique for the academic paper titled On Learning in Collective Self Adaptive Systems, State of Practice, and a 3D Framework. The paper was written by Mirko D. Angelo, Simos Gerasimou, Sona Ghahremani, Johannes Grohmann, Ingrid Nunes, Evangelos Pournaras, and Sven Tomforde. It was presented at 14th International Symposium on Software Engineering for Self-Adaptive and Self-Managing Systems in the year 2019. In brief, the paper deals with the concept of collective self-adaptive systems known as CSAS. By definition, a CSAS is a distributed and interconnected system composed of multi-agents that can perform complex tasks such as environmental data collection, search and rescue operations, and discovery of natural resources. One of the biggest characteristics of CSAS is that each node is given learning capabilities. As the deployment method of a CSAS is distributed in nature, implementing self-adaptation through a centralized control could create limitations and may not prove to be the best solution. This is where the paper tries to do more research and come up with a solution framework which tries to fill in certain gaps in this area. As explained, a CSAS is distributed in nature, and due to this type of deployment, the self adaptation control can't be implemented in a centralized or a hierarchical manner. If the control is implemented using a single autonomic manager or an observer/controller tandem, the monitoring process heavily relies on certain assumptions which can create bottlenecks and roadblocks. These assumptions include the autonomic manager's ability to obtain a consistent and complete system wide view, and its capability to process this information and distribute the decisions on time. Another problem with centralized control is the constraints on scalability and the introduction of a single point of failure, which affects the resilience of the system. As the CSAS node interact with each other either in terms of information or the form of actions, the other challenges include effective coordination, conflict resolution, and avoidance of suboptimal behavior amongst the various nodes. In recent years, the concept of interconnected software systems has been rapidly growing with a lot of application in the real world, and a lot of research is going into this field for improvements. With more and more domains being covered by such interconnected software systems, the complexity increases exponentially. As such, systems could be at the receiving end of dynamic environments, evolving requirements, and unpredictable failures. During operation, these systems might encounter several unexpected scenarios, including variations in system performance, sudden change in the system workload, and component failures. Apart from all of the above factors, the constraints mentioned in the previous slides, it becomes extremely complex to mitigate all the shortcomings being faced by CSAS. Although learning has been explored in many CSAS applications, selecting suitable learning models and techniques remain a significant challenge that is heavily influenced by the expert knowledge. Thus, it is inferred that there are gaps in the way even the learning techniques are chosen, and such a gap translates to real life applications as a performance or a reliability issue. Thus, this problem is a current challenge which needs more research and thorough study. In CSAS, learning of each agent is crucial. This allows the agent to both instantiate learning models using the knowledge acquired from observing the environment and their peers, and to refine these models by assessing the outcomes of their actions. These employed learning models can help improve quality attributes like performance and cost of either the individual agent or the system as a whole. Having justified how learning is important for CSAS, a lot of research has been done by people in choosing of a learning technique. The use of different type of learning models in CSAS is a handcraft process that relies heavily on domain expertise, which means the research done till now has a narrow view for the selection process. Each research is done from the perspective of the domain in which CSAT would be deployed, making the chosen solution to be tailor-made, which can be stringent and non-universal. This is an inherent limitation as CSAS can have agents in drastically different domains. Some people have researched to gauge the benefits of using self organization to address the challenging research issues in multi agent systems, while others have investigated the difference between cooperative and competitive multi agent techniques. Moving on, now I will discuss the author's idea for the solution to the already explained problem statement. I will start this with the approach which the authors follows. The first things the authors did was to take into account a consolidated and complete definition of CSAS, which is that CSAS are distributed systems comprising of multiple agents such that each agent has the characteristics that it can interact with other agents either directly or indirectly. It does not individually process system wide knowledge. It can exhibit learning to expand its personal knowledge. It can make decisions based on collective or aggregated knowledge from some of its peers. Doing this helps them create an objective for their research in a more consolidated and pragmatic manner. As it is already established that a lot of research has been done in the field of learning techniques, the main issue here is the selection of right technique, and to facilitate that, the authors do a systematic literature review of 52 related papers. Having done a review helps them formulate a generalized 3D framework. They start by defining their research methods, research questions, the selection process of papers, and selection criteria. Based on the defined research method, they do the review and analyze the data collected. The analysis of the selected literature, focusing on CSAS applications with decentralized learning, enables the authors to identify the key characteristics of learning process in CSAS agents. These characteristics are the basis for a framework comprising three dimensions, namely autonomy, knowledge access, and behavior. This revealed that learning tasks, emergent behavior, and learning techniques and triggers play a key role when designing learning enabled CSAS. As all the previous studies in the field mainly dealt with solutions which are tailor made for the domain where it is being applied, the new solution provides a generalized framework for analyzing and choosing a learning technique for CSAS based on the requirements which directly affect the dimensions of the 3D framework. These dimensions provide a comprehensive view on which techniques could be best suited for a particular requirement, filling the gaps in the knowledge. The given framework also talks about data privacy, as a CSAS system will interact with the user and may save sensitive data. In terms of evaluation, as the proposed solution is a framework which aims to facilitate and streamline the process of selecting learning techniques, the authors try to take use cases of applications which help them classify all different types of applications within different levels of their 3D framework with varying dimensions. Finally, the paper deals with a good topic and tries to evaluate all the possible categorizations that can be done based on applications in different types of domains. The paper does lack in the evaluation part of the solution, where a clear evaluation is missing. Also, the paper talks about the threat to validity, which is a big limitation to this paper. Further, the limitations and potential future works are not discussed. The paper has been well written and is written in a well mannered structure. The paper is easy to understand and follow. It also displays data collected in a clean and well structured table. That's all for this paper. Thank you.